Okay, good day everyone, and welcome to the final of the 4 sessions of this Housing Europe organised Renovation Summit in partnership, of course, with our colleagues at IUT. This final session will be looking at the financing to increase the circularity in housing, and we're very happy that it's being run in cooperation with our colleagues at Houseful, which is a EU Horizon project, but we'll hear more about that in a moment. So I'm just going to run you very, very quickly through the agenda for today. So again, we're just beginning now and we'll have you finished about 5 o'clock. So I know that some of you probably have things you have to take care of at that time. So we'll try and get you out of here on time. My name is Dara Turnbull. I'm the research coordinator at Housing Europe. In a moment, I'll be passing you over to our moderator, Juliana Davis Cantillo. Our first presentation will be from Xavier Pont, who is the project coordinator at the Houseful project, and he'll give you a bit of an overview about what we're trying to do in terms of promoting circularity in buildings. Then we'll have 2 case studies. The first case study is the Vaterhamn Swedish circular public housing project. We'll hear from Per Lofstedt from Yellon. Our second case study is Alexander Kongshaug, who is an architect from 3XN GXN Architecture based in Copenhagen, who'll be running you through the Circle House project. Then we'll have a presentation from Kevin McGillicuddy, who is a senior economist at the European Investment Bank, and he'll be talking about the funding opportunities of the EIB and what they're trying to do to incorporate circularity as one of the pillars as part of their effort as being the Europe's Green Bank. Then our final presenter will be Elma Dermasiewicz, who is coming to us from Amsterdam today. She's the director of the Dutch Laboratory for Green Transformable Buildings, and she's also head of reversible building design at 4D Architects Amsterdam. So that is all from me. I'm going to hand you over now to our moderator for the day. So Juliana Davis Cantillo is the program officer on climate finance at the Fonds Mondial pour le Développement des Villes. She's currently in charge of FMDV's involvement on the CHIC project, which is a European project to promote the development of community land trusts in Europe. The FMDV is a global network of local and regional governments whose mission is to develop and promote solutions for investment and financing of urban development. Prior to joining the FMDV earlier this year, Juliana worked as policy advisor on international climate finance at the French Treasury. Juliana, thank you very, very much for agreeing to moderate today's event, and I give you the floor.
Thank you, Dara. I'm very happy to be here and to be able to moderate this panel. As Dara said, we have a very diverse panel of presentations, and I will not take very long to start the session. I think we already have an overview of who will be presenting and the different presentations that we will have. So I'll just give the work to Javier Ponte, who, as Dara said, is the project coordinator for Houseful. Javier is a project coordinator of the EU Horizon 2020 Houseful project, which has partnered today with Housing Europe in the organization of the event. He works at the Leita Technology Center in Barcelona, and where he and his colleagues are working with more than 45 countries and developing projects in the fields of biotechnology, health, advanced materials, chemistry, renewable energy, and new production processes. So you're very welcome here today, Javier, and the floor is yours.
Thank you very much both for the kind introduction and also for inviting me to be here. It's a pleasure to present, at least in 5 minutes, in a nutshell, what Houseful is about. As you may have said, I'm a project manager in Leita Technological Center in Spain. Now I also coordinate the area of project coordination in our center. And also, as you have said, I'm the project manager and part of the coordination team of Houseful in Leita. So I will now share the presentation. Maybe you, I don't know if you will share it, but I will do it right now. All right, so can you see my screen right now?
We cannot see your screen.
No? I will try then again. Let me see now.
Now it's working, I think. Yeah.
Yeah, okay. And I think now if I just put the presentation mode, I think now it's working, right? Sorry for the technical problems. It's been the first speaker. As I said, Houseful is a very interesting and challenging project. Its title is the one that you see here. It's innovative circular solution and services for new business opportunities in the European housing sector. And it was funded by the late finished Horizon 2020 framework program. And just to give you a little bit of the first introductive data about the project, it was funded under a topic called Systemic Innovative Approaches for the Circular Economy. So it was rather a bottom-up topic where we proposed the housing sector as the sector to be implementing circular solutions, and we formed a partnership of 15 different entities across Europe in countries like Spain, Austria, Belgium, the Netherlands, Italy, France, and even Israel, and others that I may have missed. We are formed by both research and technology organizations, technology providers and developers, architecture companies, and also social and technological consultancies that help out in other tasks that I will be summarizing right now. And the action will have an approximate cost of 8.5 million euros. The project was started in 2018, so we are now more or less a little bit farther than the middle of the project, and we will expect it to end at the end of 2022. So in a nutshell, the main objective of Houseful is developing and also demonstrating a series of circular solutions, 11 to be more precise, in 4 different front-runner buildings I will be talking about later on. And what is most importantly, and it's the core and unique characteristic of this project, is that these solutions will be also co-created by stakeholders in the whole housing value chain across Europe. So these circular solutions are centered in these 4 these 4 applications on the materials of the buildings, the water management, and also waste management and energy savings, and also a series of solutions that also considered holistic. Now we'll be talking about later on. So the whole solutions system will be presented as an online software as a service, enabling the replication of the proposed circular solutions offered to the different stakeholders, and in the form of renting, leasing, or customer services, or a combination of all of them. The core of the project is the demonstration of these solutions in 4 buildings that were proposed at the beginning and also during the project execution. And so there are 4 buildings, that 2 of them are in Spain, 2 of them are in Austria, and are distributed among Europe. So for the different characteristics that were selected, and with the help of our community, our collaborative community of housing experts, we will, apart from this demonstrating these solutions within the project execution, we will try to replicate these solutions into 10 follower buildings that will be in our objectives that they implement some of these solutions afterwards using, of course, their own funding, but also with the Houseful participants helping them on that aim. As I said, more or less, we are in this stage of the project. Right now, in the middle of starting implementing the solutions in the different demo site buildings. So going a little bit in detail of the solutions offered, the holistic ones are the service as a software itself, and also solution 1 centered in the calculation of the building circularity. We're developing a tool to make this calculation. Is one of our main challenges. And also solution 2 is the multi-actor approach that I was talking about, by a continuous social analysis. And here on the left, you can find the main partners that are dedicated to these three solutions that I have just talked about. And mainly they are our tech providers and also our social experts in WMB. Going to the next kind of solutions, one centered focused on the materials of the building. We are developing a solution using the Madaster repository as a reference tool for producing the material passport of these 4 buildings that I just talked about, and also assessing the local circular materials available around the front-runner buildings for the building renovation. And also our tech providers, some of our tech providers are in charge of these solutions here. So going to the next group of solutions, solution 5 and 6 are focused on the water management and more concretely the reuse of the great water. Solution 5 is focused on the segregated, and solution 6 is focused on the non-segregated wastewater streams. Then regarding the waste management, more complex, there are 3 different solutions. Solution 7, first of all, divided into 3 because it's a process of using the black water and treating the black water in order to finally produce biogas for energy production. Solution 8 is the treatment from using an innovative technology, which is called anaerobic membrane bioreactors. Anaerobic MBR here in the slide, as you may see. The digestion of the anaerobic solution using already commercial configuration, and then afterwards the biogas cleaning for the commercial use and also for the energy production. So these are the partners that are developing this technology, as in the previous slides. And solution 8 and 9, separated from the 7, are centered first of all, focused on the compost production from bio-waste and digestate, and finally the assessment of the optimal management of waste at the end of the building life cycle. And last but not least, the solutions focused on the energy saving in buildings, we find solution 10, which is dedicated to the implementation of solutions for higher energy materials, and solution 11, which will aim to ensuring the energy efficiency in buildings by applying different solutions. And here the multi-actor approach and the feedback from the whole value chain, and most completely also the maintenance and inhabitants of the buildings is very, very important. And with this, I will end my presentation. I hope that you have a clear overview of our project. Thank you very much.
Thank you very much, Javier. Before I pass to the next speaker, please, everyone note that you can ask any questions you might have, but by putting them in the Q&A box, and we will have a Q&A session at the end of the presentations. So thank you again. We will now go to our first case study presented by Per Lofsted. It's about the Vaterhem project, which is a Swedish circular public housing project. So Per is a brand strategist at Yellen in Sweden, which brings together the fields of architecture, product design, and advertising. He has been in the communication business for 40 years, working with Yellen for at least 10 years. And he's also the founder and project manager of the concept. He is here to discuss the development of the concept in public housing in Sweden. So with no further ado, Per, I give you the floor.
Yes, hello. Thank you for the nice presentation. And I will try to share my screen, see if that works. I think you should see something now.
Yes, it is working.
Good. So I have 10 minutes to describe something that I have worked on for 5 years. So I'll try to make it brief. And the most interesting topic today is economics. So I will pass through all the technical stuff quite fast. The project is called and it is aimed to be 100% self-sufficient housing, where we also talk about the topic social sustainability, and economic sustainability, as well as the environmental issues. And it's, see if I can change my screen. Yeah, and it's called YEA. It's an abbreviation of Yellon, our company, Environmental Aesthetic Housing. And it's a positive word, we think. It contains a lot of technologies, such as, of course, a very nice climate shell, solar cells, mostly PVT, photovoltaic and thermal panels. We have termite ventilation. We do use hydrogen gas, which we produce via the solar cells, and that we can convert into electricity through a fuel cell. We have we run the house's electrical energy on batteries. We need a lot of thermal energy because we get a lot of thermal energy from the PVT cells on the roof and the facades. We get thermal energy in the process, the electrolyzer process, making hydrogen gas, and we do get a lot of thermal energy from the fuel cell process. And that thermal energy we can store below the house in a thermal energy storage to use it in the cold winters up here in the north. We clean and recirculate the gray water, so we use it again and again and again, not for drinking, but for cleaning and washing and taking a shower and such. And when we reuse that water, we do save a lot of thermal energy because the gray water has a lot higher temperature leaving the house than entering the house. So we keep that energy inside the house and use it again and again. The water use mainly comes from harvesting rainwater from the whole building's plot and from the roofs. But since we recirculate the water, we don't use so much water. So it will be enough using rainwater as a water source for cleaning and showering, and for flushing the toilet. For drinking water, we use our own well, a drilled well. That way we can have cold drinking water instead of the recirculated gray water, which is warm. It has a temperature of about 30 degrees Celsius. But we want cold water to drink, so we use that from our own drilled well. The toilet, the black water, we treat in a biomimetic matter, in a totally biological process. We start with an anaerobic process where germs do their stuff, and then it's pumped over to an aerobic container where plants do the rest, and what comes out of that is actually drinkable water, but we will only use it to flush the toilet. Yeah, a lot of technique that actually works. We have had that tested. The house is not built yet, but we have had a large project involving a lot of experts to in theory see that it works, and it will work even up here in the north, where we have great need of energy to warm our houses. So we plan to build 4 houses, of which 2 are the concept, 100% off-grid, and 2 of the houses are on-grid, just for comparison, comparing everything with it, the building cost and the maintenance costs, and just to compare everything. And each house contains 22 apartments, so we plan for 44 apartments, 100% off-grid. And they are meant to look like this. And even the facades are solar cells, and the glazing are solar cells. Inside the glazing, we have our own kind of microclimate, which helps the climate shell to be good enough. So now we come to what I think is most interesting today. We made a prognosis of the economic difference between our self-sufficient house, the concept, and the standard house, standard 2020, we call that. And we take a lot of considerations into this economic calculation. For instance, service and maintenance. And that also includes, after 25 years, maybe changing the PVT panels. It includes changing the fuel cell after X years, for instance. We include the cost for electricity grid and the cost for electricity consumption, because the people in the standard house will pay that money to the energy company and to the municipality. In the concept, the people in the house will pay that money to Vätterhem instead. So we have a difference in the calculation there. And the same difference we have with water consumption, water grid, and the sewer, of course. And then we have calculated financial costs like interest rates and so. And we have calculated inflation and how that affects the economy over time. And we also have made a forecast of the development of the energy and water cost, because we see that the energy cost for electricity is quite cheap here compared to most of the rest of Europe. But our electricity grid is not sufficient anymore. We have to upgrade that, and so the electricity cost and the water and the sewer costs will go up in the coming years. So we have taken that into calculation as well. And the output of this, the accumulated result, is that the initial investment for the standard houses will end up at 13 million euros, and the concept for the same apartments, 44 apartments, will end up at 17 million euros. So we have a difference of approximately 4 million euros, and that makes up to about 90,000 euros per apartment more for than for the standard houses in the initial investment. But if we spread these costs over long term, many of the costs we can spread over 50 years, some of them over 20 years. That differs a bit depending on what what technology or what part of the house we are talking about. In our scenario, we have a capital cost or interest rate at 1.75%. And that's what,
excuse me, this is Juliana. If you can start wrapping up.
yes, that's what I'm doing now. And we have an estimated inflation on 2.5, and we have the cost development for energy and water. And as we can see here, we reach break even after about 20 years. After 30 years, we have 1.5 million better than the standard houses. And you can read for yourself after 50 years. And the lifespan of the house is about 100 years. So for the long term, it's a good investment and you can make money on this. Yes, and we also see that the cost development for the technical equipment is going down rapidly. So it's going to be even better than this in the future, in the near future. And that's it. I'm wrapped up. Thank you.
Very efficient. Thank you very much for it's a small revolution you're carrying out there, as I see.
Yeah.
Now we're going forward with our second case study. So this one is presented by Alexander Kongsha. It's the Circle House project, a Danish circular housing project. So Alexander is an architect at JXN Architecture in Copenhagen, where they specialized in applied architectural research in green materials and building technologies. And they are dedicated to ecological design research through digital processes and innovative material solutions. So Alexander is here today to discuss the Circle House project. It's a social housing project, which is being developed using circular principles. So Alexander, you have the floor.
Yeah, hi everyone, and thank you very much for the invitation. My name is Alexander, as said, and I'm from Copenhagen. I just want to check if you guys can see my screen.
Yes, we can.
Yeah, super. Well, I'll try to run through it. So here in Copenhagen, we are sitting 3XN and GXN, where GXN is sort of like the innovation department of the main architecture studio, 3XN Architects. We are sitting in the innovation department around 20 people, sharing this lovely place down to the water, where we are divided up in between the competition, the product development, and our department, the whole research and material lab. Within sort of like our organization, we try to support each other, where you could say that GXN's most important feature is that we try to implement our knowledge onto the architecture. So it becomes a practice versus research in sort of like a great synergy. And we have these main sort of like 3 focus points where we are focusing a lot on circular economy in the built environment. And then we are focusing a lot on digitalization in terms of adding sensors to our buildings and actually extracting data and knowledge from them so we can learn from them. And then we have a bunch of PhDs and collaborations focusing on behavior, like how does behavior shape architecture and how does architecture shape behavior. So that said, today I'm going to be showing you Circle House. Circle House is right now a demonstration building. It's going to be 60 units in 2023, I guess. And the main idea with Circle House is that you're supposed to being able to reuse or upcycle 90% of the actual volume and all the principles which goes into the house. So the main idea is, you can see here on the screen, that we are trying to avoid linear economy, moving towards a more circular economy. where it's not only just about reusing the whole volume, but also all the technical aspects, time and education, which goes into these buildings. So today, this is a typical picture here in Denmark of how we build. We have a massive concrete industry, and it's going quite smoothly. Everything fits and everything is paired up with a BIM model. So you're quite sure of when you're reaching these modules or different kind of slabs and so on, they actually fit on site. But then when we tear down, it looks like this. And there are just so much knowledge, so much time and education and volume, which goes to waste when we are tearing our building down just like this. So we want to sort of like be able to say that it could look or potentially look just like this when we actually demolishing our buildings. And for us, it's super important to state that it's obviously we have to be more environmentally focused. We have to be more sustainable. But when we talk to clients and say that, okay, we have a circular economy agenda and so on, they often ask us, what does it implement? And for us, it's just a big thing to be able to improve the lifespan, to reach a higher flexibility throughout the building's lifetime, but also on site, while we're actually building, that we can gain a faster construction. And then throughout also the lifetime of the building, that it's easier to sort of like operate and service. So based on sort of like those three principles, we started designing this whole strategy behind Circle House. We made a small book, we made a great collaboration and tried to sort of like through this exhibition, reaching out to local stakeholders or local producers and entrepreneurs, which could be a part of this development, because it was super important for us that we were not alone to actually develop this concept. So we teamed up with 2 other architectural studios, and then I think over 60 different stakeholders within the build industry to actually share, create workshop, but also to actually build up strategies which would work for all the stakeholders along the value chain of the lifetime of the house. So the main idea is to create sort of these different layers where the house would be dismantled throughout its lifetime. But you can see here, this is the site. This is the second largest city in Denmark. It's called Aarhus. So the site is just north of Aarhus, existing of these 60 units, which is designed to be able to be put together for 4 different typologies. But the system behind Circle House, as I said before, is that we want to be able to service it throughout the lifetime. So we, some of you have probably seen this diagram before, but it's all about the different layers of the building. So just like that, we are waking up in the morning and we're taking on different layers of clothes. The house also have different layers, but we divide them up into different lifetimes. So everything that goes inside the house as countertops or towels or carpets and so on could be within the 5-year span, and then you sort of like you go up in span where you end your lifetime in the main construction of the actual building. But we wanted to be able to separate these different layers. So that's why the whole Circle House strategy is supported by design for this assembly. So you would be able to actually dismantle the house layer by layer in terms of where you would need to service it, change the facade, change windows or doors, and just sort of like optimize the operation of it. So going to the constructors, we reached into the big concrete industry in Denmark. And that was very much on purpose. There's been a lot of people who asked us why we wouldn't do it in wood, because then we would gain the CO2 emission down, and we would have a nice, lovely smelling house, so on. But we actually wanted to address the concrete industry in Denmark to be able to so like challenge them and to give them another opportunity of becoming more sustainable. And by doing that, we wanted to innovate on their actual concrete slabs, and to be able to go into the whole story of reusing and upcycling and so on. We needed to keep tracks of these concrete elements which we were added into our structure. So we, in cooperation, developed this RFID chip, which we then casted inside the actual concrete elements. So you would be able to read the chip and then go on an online or a digital archive where you would get all the information based on the slab, and that would be everything from what is produced of, who made it, what was the statics behind it, and what was the lifetime, and how would you actually disassemble it and reuse it, and what could you be able to reuse it for. And we think this is a layer which should be implemented in all the materials and module which goes into our building. So here we're looking at a digital solution, but there are the digital sort of like movement is moving very, very, very fast. So let's say the lifetime of this house was 100 years, and you were supposed to reuse it by logging onto this chip. It would be a bit like trying to read some very outdated technology. So there are many ups and downs in this sort of like application of material passports to this today. You go on this.
Alexander, if you can start wrapping up.
Yeah. So it's based on these 3 slabs here. And you can see how we combine the actual demonstration. I'll just move forward to some of the more exciting pictures. There you go. So 3 different modules put together, and then this module is a demonstration where you can see them being put together, and it took a half a day, 2 men and a crane, and you could screw and tighten all the slabs together and all the modules. And then what you saw before is that we had these open mechanical joints which we had to cover up with mortar. With chalk mortar, so we could actually by applying this chalk mortar, you could remove it with a strong water hose and then access the mechanical joint and disassemble the whole house again. And then we use the demonstrator to apply different kind of material solutions, which all go into the whole reuse and upcycle strategy. And here you're looking at dragon shells made of household plastic waste, which we applied to one of the facades. And here you're looking at another system also made for disassembly, where we sort of like hacked the whole installation system behind it. And then we went to the metro construction and reused some of the waste wood from the actual building site, and then transformed it, burning the top layer of it, so we would make it resistant towards weather and rain and so on. And then again, when you go into the house, it was super important for us that there is a bunch of solutions from the Danish producers, which actually all support the whole circular economy, where you would have the floor without glue, so you could take it apart. You would have curtains based on upcycled plastic bottles, and you would have old lamps from industrial building transformed and optimized in terms of which techniques go inside the lamp. So all in all, like a fully circular house, which we were 60 different stakeholders to build and to showcase, which is now in 1.5 years' time is going to be 60 units standing with this whole design for this assembly concrete system north of Aarhus, second largest city in Denmark. Yeah, that was it.
Thank you, Alexander. Extremely interesting, both the national economy side of it and the traceability of material. So thank you for that.
Thank you very much.
We will now go to Kevin McGillicuddy. He is a senior economist at the EIB. He will be talking to us about circularity as a pillar of Europe's Green Bank and the potential of the new EU taxonomy. So as I said, he's a senior economist at the EIB, and he has represented the EIB in consultations with the European Commission on the development of the EU taxonomy for sustainable investment. So Kevin, the floor is yours.
Okay, good afternoon. Just bear with me to make sure I get the presentation shared.
And your camera, please. Just on a quick note, it's 4:12. We have until 5 p.m. So if we want to leave a bit of time for the questions, we have to try to be as efficient as possible. Now I see your screen.
Okay.
Perfect.
Okay. And can you see that now?
Yes.
Can you see the presentation?
Yes.
Yeah. Perfect. Okay. Thank you very much. I'll try and go through this very quickly. Really interesting to see the demonstration projects. I think what they do is they give us an indication of where the innovation's coming from in the industry, and I think it neatly dovetails into what EIB hopes to achieve with its ambitions as the EU Climate Bank. And I think what I'll do is I'll just go through rather quickly a bit of background about EIB, because not everybody knows the workings of EIB, and then I'll touch upon the areas of housing, our involvement with housing, and then our recent works in relation to circular economy and the taxonomy. So with that, just very quickly, EIB, for those that don't know, it's a policy bank. It's the EU policy bank. So we focus on funding projects that achieve the public policy goals of the EU. And it's also happens to be the largest international finance institution. We're located in Luxembourg, where we have 50 offices and a rather substantial staff size of 3,400 people. What is important for us to know is that in terms of the housing, it falls into the infrastructure pocket, but you can see we invest in renewables, infrastructure that's much broader beyond social infrastructure like housing and supporting innovation, and very importantly, SMEs, which is really the backbone of the economy of Europe. Okay, and then just very quickly, just to contextualize housing, it falls under the urban agenda. Our main focus is integrated urban development. There we're encouraging developments within cities to ensure that there's a reduction of sprawl. We also are keenly focused on kind of horizontal agendas like climate change and, as I mentioned, innovation, and the social dimension of inclusion, eliminating poverty and inclusion, and then the other aspect of supporting governance throughout Europe. Just quickly on the housing, it's again, we're there to support regulatory framework. Everything is focused on the integrated planning approach, and we'll never support a project that isn't supported by the local planning and driven by the local planning ambitions. And probably important to note that our housing is focused on social and affordable housing and not for market sale. EIB doesn't deliver additionality. related to the commercial markets for sale or for profit housing. So that's a delineation for us as a bank. So who do we lend to? It's housing companies. Some are municipal loans, some are approved housing bodies. We obviously lend to cities in much larger framework loan investments. We also lend to banks, and banks act as intermediaries for us, where the banks can basically they're more efficient at making smaller size loans. So they serve as an intermediary, and EIB finds that a very successful relationship. And of course, we also lend to housing finance institutions. For those that know the HFA in Ireland, they are one of our intermediate borrowers, where they then lend on to approved housing bodies. So that's some of the ways that we work. This little bit of a replication, but just EIB is a policy taker, so we understand what the EU lawmakers are setting. We then modify our approach to our lending strategies, and as I mentioned, our main focus on the housing side is social and affordable housing. Quick snapshot here, just to see the lending volume for urban lending, and as you can see, it's quite diverse. It's not only urban development, transport, education, all the main urban infrastructure elements, but also on the social side as well. Leading into the next conversation, EIB has set its ambitions to become the EU climate bank. And what that means is that there's an expectation over the next decade to invest up to €1 trillion for projects that are related to climate action and environmental sustainability. Now, one aspect is this will be about 50% of the total lending volume that EIB does. It doesn't mean that the other 50% are not green, do not fit this ambition, but some of it is supporting digitalization, security, social investment, and SMEs. And so that's the other pocket. Will that change over time? I think even those areas will start to green as well. But in terms of the broader ambitions, by 2025, 50% will be climate action and environmentally sustainable. As of this year, all our investments are 100% aligned with the Paris Agreement. So how do we look at investments? Well, first we have to meet existing eligibility requirements. So that, again, this goes back to public policy goals of the EU. So SMEs, lending to SMEs, integrated urban development, energy efficiency as examples. We're then Paris aligned as a bank, and the other fine layer to this is projects that deliver climate action and environmental sustainability. Just another framework for this, of course, is the investment plan with the EU Green Deal, and much of this is marrying up with what EIB has been doing for quite some time, but also looking at key aspects of the much broader aspects of restoration of ecosystems and biodiversity, looking at healthy and environmentally friendly food systems, and the renovation trends of renovating projects, which is going to be a major focus for us. So here you can see circular economy is one of the aspects. EIB has already issued its circular city funding guide. Our focus is on the renovation wave, and there's other aspects that you can see here that EIB is making an effort towards to support the Green Deal. Just one clarification on climate action, environmental sustainability, and Paris alignment. I think the key aspect to this is what the bank will be looking for is a substantial contribution to CA and ES, and that's part of the EU taxonomy, which I'll just touch upon. The fundamental aspect here is making sure that there's no significant harm to climate change or the other aspects of the climate ambitions. So EIB, just in terms of its climate bank roadmap, we've set an ambitious energy lending policy, which started in 2019. We adopted the climate bank roadmap in 2020, and in 2021, ahead of the criteria for environmental sustainability, we've adopted some initial measures and criteria that is running in parallel to the taxonomy. Again, just a focus on the energy lending policy. This is a key aspect for renovations. We can finance up to 75%, and this is really just supporting. It's supporting the social and affordable housing industry. We're also for new development, which is another key aspect of housing. We're looking at projects or encouraging projects to go beyond current existing NZ criteria. And for those that don't know this, just a quick refresher on the EU taxonomy. Where does circular economy fit within it? It's one of the environmentally sustainable public policy goals, and that's just one of the bank is focused on contributing finance towards all of these aspects, all of these environmental objectives. Again, this is looking at what qualifies in the taxonomy. You have to contribute at least to one of those public policy environmental objectives, and then ensure that there's no significant harm. So what we've done, and this is a little bit of a laboratory for the bank, because the EU taxonomy is currently working on its own criteria. We've engaged with some studies on green buildings. We've looked at all the aspects of those four or actually 6 public policy goals. And of the 4 related to environmental sustainability, we've drafted some initial concepts around circular economy and the other 3. And more than likely, there will be a feedback loop here with once the taxonomy gets some further definition on how it's approaching these 4 environmental sustainable objectives, we will then kind of fine-tune our own criteria. So one of these aspects, and just to thank 3XN or GXN or both for their some of their visuals. This is something we picked up on when we did an internal green building study. just some of the innovation that they were introducing, and this was probably about a year ago. So for circular transition, or the transition to the circular economy for buildings, we have a prerequisite, and basically a project has to set out a statement that commits to contributing to the circular economy, and then details how it approaches it for in the project design. The other layer to this is, okay, I have to wrap up. Okay, we look at the 4 circularity categories. In here is everything from black water recycling to looking at design, reusing materials, looking at life cycle assessment, digitalization, similar to the likes of Madaster. So it's 3 out of the 4 categories. We need some type of contribution. I'll just quickly go through the last 2. It's, we address water criteria, which again, there's water reuse there, and importantly, pollution prevention, which is related to your indoor air quality. And last but not least, biodiversity, which is about preserving or restoring, or if it can't be done, it's contributing financial support in other areas. I'll just conclude with the fact that not only are we a lending institution, we also have numerous advisory elements where we encourage engagement that either are on the front end of a project, or helping larger organizations like cities develop their own strategies towards the environmental objectives. And that concludes that, and I thank you for your attention.
Thank you very much, Kevin. Yeah, it must be quite a tough job to be Europe's largest funder, right? And with such a moving policy agenda. So thank you for trying to wrap that up that efficiently. Now we're gonna finish with Elma Dervisevich on the analysis of the costs and benefits of circular housing development. So Elma is the director of the Dutch Laboratory for Green Transformable Buildings and the head of reversible building design at 4D Architects in Amsterdam. So Elma, the floor is yours. It is 4:30. If we can try to have at least 15 minutes for the Q&A before it's 5 p.m.
Yep, this will be a challenge, absolutely, because this is such an interesting subject, and I enjoyed very much listening to the previous speakers and seeing the great pilots and projects being done. So yeah, I will actually touch upon briefly on some lessons learned from another Horizon project. I was initiator of that project as well, Horizon Buildings as Material Banks project, where I was myself leading the development of reversible building design toolkits, and many things I heard today do reflect many discussions we had during that project, which has been finalized in 2019. And then I will also tell you something more about another very interesting and groundbreaking project in the Netherlands from Urban Innovative Actions, which was literally trying to figure out what is the capacity of existing buildings and whether they can be used as material banks for future buildings. But to start with, I just want to put some more light on this screen, why it's here. Basically, I wanted to give some reflection on why is circular economy, why is it seen as the key challenge of society today. And I think this map, which has been developed by World Bank, and has been developing, they have been developing these maps yearly, represent, I think, very much what the challenge is, represents the pace of use of resources and how we stand today. The 1961 map obviously shows more green planet with many more countries which had lots of resources which they were not using and they did not need per year. So it was not needed for the yearly consumption. And we see that in a map in 2016 is indicating that the planet is becoming more red, and that means that there were more and more countries who were using and consuming 3 to 4 times more resources than they had at disposal. And obviously that we all realized that the planet is kind of very precious and in the end also physical, a matter which has resources, and if they are not used properly, they can vanish, and that can, with that, our life support system can vanish as well. So it is about management of environmental capital, which is supporting our life. And obviously we need to figure out what kind of financial systems need to be put in place in order to reverse these negative impacts of our actions and use and consumption so far. So when we talk about buildings, obviously we see that buildings are frequently being changed, and that means unfortunately demolished due to the degradation of materials, inability to accommodate different new functions. Buildings are then just again demolished. So we see that basically this approach to construction, which is more linear, we design buildings, we use them and demolish them because they were not designed to be modified to new use. The parts are not designed to be recovered and reused. This approach led to the fact that building construction today is one of the most important and responsible industries when it comes to the CO2 production, use of raw materials, and waste production. So I'm sure many of you have seen these figures already. I'm not saying any big news today, but I think that the key obstacle in going forward with the circular material streams within built environment lays in our perception of buildings in general. How do we perceive buildings? We perceive buildings as static structures, structures which are there for certain use, and then once that use is not needed anymore, we demolish it and build a new one. So that was a kind of linear approach which we have applied to our built environment, especially in the last 150 years. But obviously, the very purpose of architecture and construction is to provide shelter and comfort to human activities. And human activities are very dynamic. And I think this slide gives you just a small glimpse on the dynamics only of our lives, but besides that, living in a house, all other activities or daily activities, work, sports, and so forth, are changing all the time. And there is this tension between the dynamics and ever-growing dynamics of use of buildings and the way they are obviously built. And it is that tension that needs to be resolved, and it is that tension that is tearing buildings apart and creating the negative impacts on the environment. So where we want to go with the future generation of buildings, we call them within BUMP project reversible buildings. That will help us to create a new world, an upgradable built environment made of a building and modules which are reconfigurable, can be exchanged, upgraded, and brought back to the built environment, and where the construction industry will not be organized around demolition and construction of new buildings, but it will be organized around transformation and upgrading of the built environment. And that applies that we should see circular buildings as, and design circular buildings as reversible monuments. If we would like to end up with our upgradable environment. And that would, for the architects and designers, require an understanding and design of two key capacities of our future buildings. One is spatial reversibility of buildings that will enable this modification without demolition, and the technical reversibility that will of building elements and structure that will enable this reuse and recovery of elements in a building. And just one example of how these reversible monuments will look like. We don't have to imagine very far, because I live in Amsterdam and talk to you today from Amsterdam. This is one of the many of canal houses built in 15th, 16th century, and they lived through many modifications and changed functions, six, seven functions in the last 300 years. And that's exactly what the technical and spatial reversibilities could offer, as these structures have spatial capacity to accommodate these functions, but also technical capacity, because canal houses in Amsterdam have detached facades. The floors can be also reconfigured, and so forth and so forth. So that's kind of reversible monument that I was talking about. And I'll wrap up this part of introduction very fast. In order to come to kind of assessment model that will help us understand the level of reversibility of elements, I developed, as a follow-up of our BUMP, reversible building design tools, a method which is measuring reversibility and this dependency of all elements in the buildings, taking into account the connections. And we saw a number of very nice examples of reversible connections, a number of connections, assembly dependencies and so forth, and built and connected with digital tools. And they were also addressed today, can enable us to have a real life understanding of reversibility of the structure and reuse potential of elements. And these reuse cores are then connected with the reuse options of particular element and its embodied value. Next to that, talking about spatial reversibility, also as a follow-up of the BUMP project, I finalized the technical, the tool measuring transformation capacity of building, which is assessing how easy it is to change or modify building from one function to another without demolition. And that brings me to a kind of summarized circularity profile, which is based on these two types of reversibility I was talking about. Now, having said that, I will now go to a practical project that I want to elaborate with you and share some lessons learned from. This is an area in the south of the Netherlands, in Kerkrade, where the city of Kerkrade and a housing corporation, Heenwonen, decided to dedicate this area you're looking at as an experimental circular housing area. And the aim was to transform this area by removing 3 big 10-story blocks, which you see on this picture, and reusing all materials for the construction of new houses. And besides the material circularity, which has been tested here, the water circularity, we also heard something about that today, and also social circularity were key elements and aspects of the project itself. This is how the area looks now. And I will talk about the red circle, the 3 experimental projects, which were the first ones to be built in order to understand which kind of the construction techniques can be used and applied for new construction. So the project itself aimed to reuse all materials from the 10-story building and to test different construction strategies and reuse strategies while constructing 3 new buildings I showed in a previous slide in the red circle. And that meant that the consortium really wanted to investigate what is the capacity of existing built environment to act and be used as a material bank for future buildings. What are the consequences of reusing these materials, and what are environmental and economic impacts of these actions? And that means that number of techniques have been tested, starting from literally cutting the 10-story building into the 3D modules, posting the modules out and reusing them as a core for the two of the houses. And those are the 3 houses which have been constructed in the end. This is the part of direct reuse by cutting off the parts of the building and reusing them as a part of a new building. Or on the other level, we heard something about the time levels by a previous speaker, addressing the dismantling of time levels in a building. The building also has technical levels, and in this project, the 3 technical levels of building composition have been analyzed. This is the level of element reuse, where the parts of the existing building have been or crushed to small pieces of concrete, as you see here, or cut to be used again. And the 3rd level of material which we find in the building is recycling level, this material level. That means that pieces of the concrete coming from the 10-story building has been recycled on the spot in the field factory, and new concrete has been created to construct the foundation and the 3rd house. So to summarize some of the findings, the analysis have been done to understand the environmental and economic impacts of different actions and different deconstruction techniques. In order to understand these impacts and the costs, of course, on the one hand side, we have internal costs to the construction, which are calculated by looking into labor hours, the material which is used for the construction, and equipment. And those are classical conventional costs, which we sum up and we know how much the building will cost. But when we talk about circular buildings, there are additional external costs, such as CO2 emissions, and they are calculated by taking a tax. They have in the Netherlands a CO2 ton is charged with 25 euros a ton as a CO2 tax. Residual value is the remaining value of material which is used, the market value of material when recovered. And embodied energy is an energy which has been reused by reusing elements in a building. So when the analysis have been done for the recycling of the concrete and creation of circular concrete for new buildings, these costs have been mapped with the conventional house, which had the same square meters and same typology, in order to understand the difference between this conventional method, it was also on concrete building and costs, and the circular building and their costs. And in this, on this level of recycling, it became very clear that the recycling and circular concrete can almost compete now with the market costs on them at the moment. The other test,
Elma, if you can start wrapping up, please.
Other tests were done on direct reuse of products, as I mentioned, hoisting the modules from the building and or cutting the parts of the facade in small modules. And these costs turn out to be much higher than a conventional one, and that had primarily to do with the complexity of taking and of operations needed to cut and take elements out. When we look into and compare the construction costs of the circular house and the reference buildings, it became clear that the circular house is like 2.5 times more expensive. Now, what also became very clear is that on one hand side, by constructing these 3 circular houses, there is a huge environmental gain because materials have been reused, CO2 has been reused, and energy has been reused. So there is win-win on many of these environmental points. But when we look into economics, you see that these buildings just today are 2.5 times more expensive. And primarily, as I mentioned, the process is around recovering of elements and materials from buildings which were not designed to be deconstructed and materials reused are so complex that in the end become much more expensive than needed. Now, the lessons from this have been used to construct other 15 circular houses. They have been just finalized, and they have been built with the idea, this is the first lesson, as design reversible methods of construction that will enable easy recovery. So the consortium picked up existing prefab concrete system, which has been upgraded by adding new connections and reversible connections that will enable their reuse and reusing the recycled concrete for the construction. In the final economics, the buildings have just been finalized and they turn out to be about 30% more expensive than the conventional houses. Again, with environmental gain. So this indicates that experiments are very interesting and very good to do. And learning by doing is the best way also to understand way around and how we can work around the economics and even today try to build more circular with less costs. In order to understand how to analyze costs and benefits of circular buildings, of course, we always need to compare the circular building construction and their costs with the conventional approach. And in conventional projects, demolition projects, when a building is being demolished, the owner has only costs, demolition costs, waste disposal costs. So it's only about costs. In circular building, in circular world, where we talk about this more take, make, and remake world, besides costs which are related to inventory, you have to understand what is reuse potential of materials, so the strategies to take them out, and the storage. But besides these costs, there are benefits, as the residual value of materials, benefits also environmental in terms of CO2 saved and so forth. And then what became very clear that the buildings with higher reversibility index will definitely have a low economic and environmental costs. And the last project that is under construction now in this area is the third 10-story building, where the municipality decided to demolish half of it, and other half has been refurbished and will be reused for housing again. And the demolished part will be rebuilt with the material that has been taken down. And obviously, this direct reuse of parts of the buildings which have this transformation capacity to accommodate this new function does not have to be removed is the best prevention of loss of capital and environmental and economic capital that we can think of, and why this reversible monuments will be needed. So this is the area, as I mentioned, how it looks now. And I don't know if I have time for some the findings and the summary of findings, which are quite interesting to go through.
Start wrapping up, Elma. But yes, go ahead.
So the conventional supply chain hierarchy, as we know it in the construction, is not applicable in circular projects. That is one of the first findings, because we see that the roles of the construction company, for example, is not of the materials, is in this project, for example, one of the material supplier, not demolisher. This demolition company was involved in the project from the first day. Existing building stock was not designed to be deconstructed. And that is why recovery of materials is and was labor intensive, and material is damaged during the recovery process and lost value. High labor price in the construction projects cannot compete with low price of virgin materials. The savings in raw materials, CO2 emissions and energy are high, but are not reflected in the construction costs and market price at the moment. This, due to the lack of circular building legislation, there is a disbalance between the cost of linear and circular building on the market. And without regulation of taxation policy, standardization of circular building quality, circular building projects will not be competitive on the market. This is something that policy needs to look and is looking at carefully. Recommendations are in direction of internalization of external costs as a building cost, standardization of circle building quality, and integration of a quota for the application of reused elements and recycled materials in new construction and construction products, prescribe reversibility index in new building standards. Possible options for new taxation policies would be to reduce labor tax, increase tax on raw materials, increase tax on construction waste, introduce disposal fees for projects and products with a low reversibility index. And what we see is that the biggest impact can be reached by design of new buildings with high reversibility rate. And some of these products have been also developed during this project. And the standardization, of course, of the production can reduce the cost considerably. So that would be my last slide. Thank you.
Thank you very much, Elma. And with that, we finish the presentations. So let me first do a very quick, let's say, summary of what we saw today. So we had 5 presentations, 2 case studies: the Circle House in Denmark, the Vaterhem in Sweden, the Houseful project in Barcelona, in Europe, but implemented by a Spanish organization. The potential of EIB in terms of taxonomy and green banking, and last, Elma's very interesting presentation on very technical and policy making recommendations. So I would have a very broad first question, maybe for Kevin. So we're talking about a lot of evolution and how speed is running this sector, and how policymaking is shaping circularity, how our behaviors are shaping circularity. But that also entails the fact that some people might be left behind. So some people might not comply anymore with the frameworks that are being implemented. So how do you see that, consequence of some people not being able to access finance anymore because for now they do not comply with the frameworks that are being accepted at the European level?
Well, I think from a bank perspective, the intention is to not leave people behind. I mean, one thing I didn't touch upon, but part of the EU Green Deal is supporting the just transition. So as we move forward with decarbonization, there are many areas in Europe that are reliant on fossil fuels, and the EU plans to support those type of areas with the just transition plan. So I think from a policy perspective, it's clearly focused on doing that. Does that answer your question?
Yes, absolutely. I mean, if you want to further develop, but yeah, that's enough. Okay, thank you, Kevin, for that first answer. And going forward with the role of the financial sector, maybe this is a question for Elma. How do you think the financial sector needs to change in order to allow the duplication of the project you presented?
Yeah, that's a good question. I try to summarize some key findings from this project and what has been already recommended to. Not only, I think that we need to do a couple of things in parallel. So it's not only that the financial sector needs to move and adopt some new measures, but policies need to follow. And sometimes I think it is very important to have a kind of coordinated approach in making new steps towards a circular economy in construction. But the key thing is that we do see, if you look at existing buildings, first, as I mentioned, they were never designed to be deconstructed And that's why it is really absolutely very costly and takes lots of labor to take parts out with high recovery value. So it is a design issue, but we'll put designers away. So practical issue, we have lots of labor on the construction sites. And when you match the cost of the construction with the cost of raw material, which you still can just buy, that is not working. It is not supporting. It is not supportive. So it is really very much where do we want to go as a society that will then inform policies to impose new regulations and standards and taxations in order to bring in a balance in the market to help the transition if we really want to move swiftly to a more circular built environment. So very often I say we live in a twilight zone. We are live in between a linear world, which we are desperately trying to leave as soon as possible, but we have inherited all systems from that world. And we want to step into the new circular world as soon as possible. In this new circular world, that's why I sketched this world of upgradable buildings and so forth, which absolutely require a new design approach, new methods of constructions and so forth. So we need to work on that from today or yesterday. But in between, we have this transition where we need to use as much as possible the things that we have at disposal, and also looking into the existing buildings and built environment, how can we resource them again? And we need some support from policies, and the financial sector is then needed in order to make that step, because the market conditions today do not support this transition. So I think I did mention, I will not repeat myself, a couple of points which indicate which direction we should take.
Perfect, very complete answer. Elma, maybe just to further develop this last point, what do you think about the housing stock for people living alone, for example? Because it seems that housing providers, social housing providers, have a large number of people living alone, and there seems to be a lack of stock of this profile. So do you think that the reversibility model could be applied to adapt to changing social needs?
Yes, I've been very often talking with the housing corporations and many institutions here in the Netherlands, proposing to create a kind of quick scan of buildings, housing stock, because we can categorize a whole existing building stock into reversible, partly reversible, and irreversible. And I've been always saying we need to just understand in advance which part of the stock really does not have a future value, and we should not put any additional effort in that, and then focus also. I mean, now we look into the existing building stock in general in the Netherlands, and for example, there are many offices which are empty also due to the corona. There is a difference in working, and not all of these offices will again be full. There's also a question how to use the spaces of shopping or small shops, and all the spaces. That's that part of transformation capacity index, which looks into the ability of a building to accommodate different functions and which functions. So we can make kind of categorization of the built environment and what we have, to understand what we have built and what is the capacity and future value of this, what we have, and build our strategy for the future based on these analysis. And talking about the people, starters on the housing market, we see more and more here in the Netherlands also. For example, I mentioned offices. So if office is not being demolished, then indeed the discussion starts very, very soon. Like, can we transform this office building into student housing? Or starters housing, and many office typologies do have that capacity, not all of them. But that is one of the directions that is being looked at, or even shops in the streets, in shopping streets, in some parts in the Netherlands. Some shopping streets are closed, and people don't think they will come back. So even some shops are being transformed into housing. And that is the exercise I think it's worth doing to really understand the quality of the existing stock and its future value in terms of its transformation capacity and what it can be used for.
Thank you, Elma. There are some other very technical questions, but I prefer to give all of our speakers 30 to 60 seconds each to maybe share with us their final comments. We can start with you, Javier, if you're still with us.
Yes, sorry. Yes, I'm here.
Maybe you might want to add something to your presentation or to the discussion that came afterwards.
No, I think, well, that the questions were very well answered, and I think, well, just not to add anything in particular, but just to add that all these concerns that have been mentioned regarding, well, policies and the needs, and also the requirements from a Green Deal, the European policies. And in Houseful, we are developing and following a multi-actor approach, as I said, and cooperating and engaging the stakeholders in all the development of throughout all the projects. So I think this is also the way, and this is the very, very important to mention, as I already said it in the presentation. So just to mention here, and I don't know if anybody has any other questions regarding the Houseful project, but if not, I will leave it out here. Thank you.
Thank you, Javier. Kevin, if you have any last remarks. Unfortunately, Par had to leave us, and Alexander as well. So we're only 3 left with Elma, Kevin, and Javier. So please, Kevin, go ahead.
Okay. Well, first of all, just to say thank you for hosting this conference. I mean, I thought it was really nice to see examples of how to contextualize the circular economy, because or circular economy for buildings, because for many people out there, it is still a rather theoretical concept. So I commend you on that. And the only thing to say from a EIB perspective is that the bank is committed towards the transition to the circular economy, and we're looking at above and beyond our efforts within the urban environment. We're supporting industry and innovation, and we'll continue to focus on that. So just thank you, and just to say I enjoyed all the presentations as well.
Great, thank you very much, Kevin. Elma, maybe some last words?
Yeah, not much, just as Kevin, thank you very much for organizing it. I really enjoyed as well listening to all speakers, and also seeing the practical examples and of the first 2 speakers. And we did talk, and it's very nice that there were quite many architects in this session, also, although we were talking about economics of it. Because I do believe that every transition and transformation starts with the design, and that's where we are, I think, and we need to help others understand what that transition means. What we do definitely need to redesign our way of building, rethink our way of building, and come up with new perceptions of built environment, which is not so static anymore, but can be always modified as a glove to fit as a glove to every new user requirements without demolition. So those would be my last thoughts today.
Thank you, Elma. Yes, absolutely agree with you. It's just not a matter of how good of an economist or a finance people you are, a finance person, but rather how you design what you want to finance. So with these last words, I just want to thank everyone for attending this very rich session. I understand the recording will be available online in a couple of days. So thank you again for your presence. Thank you for all of our speakers, and see you next time.